Okay, we're going to discuss derivatives now. Derivatives, when you think of derivatives, in your mind, think slope. It's a more exact version of the slope, but it is still, it looks like a slope. It presents itself as a slope. The limit definition, I told you in the last video that we use a limit definition for derivatives, and this is what it is. F prime of x, which is representative of a derivative, that's how we show that we're taking a derivative, is this messy thing right here with delta x being a very small, infinitesimally small number. Now, this is an introduction to derivatives, so we're not going to dig into this like we would do in a calculus class. If you take a calculus class with me or in college or whatever, you'll break this thing down and actually do formulas. You'll actually do derivatives using this formula. Once you use it a few times, though, it's not so bad. Just it takes a little getting used to. Just know that delta x is really small. All right, we're only going to cover these three rules that come out of this limit definition. First one's going to be the constant rule. You know, what is the slope of a number? Let's say our number is 3. Okay, what is the slope of a 3? Well, we know that with a constant, the slope of y equals 3 is just going to be a straight line, or it's going to be horizontal. If I go to my graph here, you can see that is that red line there. That is a constant of 3. What's the slope? It's nothing. It's 0. So you can see I put it in there. It's the red one there. y2 equals 3, and we can see it's flat. Okay, the next one is the power rule, and that's going to be our derivative equals, and we have to take our original equation, and if we have an exponent up here, we have to subtract 1 from it, and we have to take that exponent and put it out in front. So if I'm taking the derivative, back to our example here, if I'm taking the derivative of x squared, that's our blue one there, then what I have to do is I have to take that exponent, throw it out in front, because that's my n, that would give me a 2, and then it would be x, and then my exponent, I got to subtract 1 from it, so it'll be x to the first. We'll cover this one again, but once again, we're looking for slopes. What is the slope in here? And we can get that by using the power rule. Last one is a constant multiple rule. If we have a constant out in front of our power rule, let's say we had like a 5 out here, it stays out there and multiplies against our n. Okay, let's move over to our sheet here and start solving some of those, or some of these. There are 18 derivative rules. We're going to cover those 3. Just talked about them right there. And here are the formulas for them with examples. Our derivative 3 would be f prime of x equals 0. Now make sure when you're taking a derivative, you always put that you're doing a derivative. In these examples, we're going to use f prime of x. However, there are other ways you can show it. I want you to show it with f prime of x. That's the most common that we see in our books. The power rule right here, derivative 4x squared would be 2x. Here's the formula here. We use that formula in there, and we would end up with the 2. That's our n out in front, x to the minus 1. Well, what is x to the first power? Well, you could just drop that off, and it would be 2x. All right, the constant multiple, here we have 2x cubed. Our derivative would be our 2, which is our c value. That's our constant out in front. That just stays there. Our exponent, our n, would be 3. That goes out in front. And then when we're using our power rule, there's right there, it would be 3 minus 1, and we would have 3 minus 1. Multiply everything together and get 6x squared. And that would be the derivative of that equation there. Okay, so let's work on these problems right here. The first one, the answer is going to be 1, and I'm going to show you how we get that by using the power rule. So if I have x, that's actually x to the first power, isn't it? So if I move that over here, and I'm going to take the derivative of that, if I use the power rule, I got to take my n, throw it out in front. Wouldn't that be a 1? And then it would be x 1 to the minus 1. Well, this right here is going to end up being a 0, and anything x to the 0 power is also going to be a 1. So that's how we end up with a 1 here. 1 times 1 is 1. And that's how that one works for this particular problem. Okay, moving on to the next one here, we have x to the 4th. We're going to use the power rule in this one also. So x to the 4th, if I use my power rule, I got to take my 4, my n, put it out in front. It's going to be x, and then I got to do n minus 1 for the top, and that would be my answer for that. Next one's e to the 4th. Wasn't that a number? Isn't that a constant? Go right out to our constant rule. Anything that's a number is, its slope is a 0. 5x, once again, this is going to be a constant multiple rule. I'm going to do the same thing I did up here to show you how this is solved using the power rule. And what happens is I put my 5 out in front. This is to the first power, so that would go there. This would be x to the 1 minus 1. That would end up just going away because x to the 0 is going to be a 1. 5 times 1 times 1, and we end up with just 5. So the x goes away on that one. We end up with just a slope of 5. Last one's kind of tricky because this turns into, if I take this and I change it into its exponent form, fractional exponent form, I get this. I'm still going to use the power rule to solve this one. And notice I'm doing this every time. I'm always putting this f. I didn't do it here, so that would actually be incorrect. I actually have to, here we go, fixed it. Got it here, there. Okay, so we're all good. So f of x on this one, if I use the power rule on this, turn this sideways here. If I use the power rule here, I take my 1/2, put that out in front, end up with x, and that's going to be 1/2 minus 1. Interesting. So on this one, what I'm going to end up here is actually a negative 1/2. What do we do with that? Well, the negative is going to put the x down below, and we're going to do a radical again on it. So what I'll end up with is 1/2 times 1 over, or I could just write that as 1 over 2, like that. Okay, there's 5 of them for you to do. I don't have the other page there, but you got 1 here, and then you got 4 others behind that. Go ahead and turn those in, and you'll be good. Thank you.